Hi there. Welcome back to the series on Azure pipelines on Docker. In part 1, we deployed containerized Azure pipeline agents to AWS ECS Fargate. We got them running, we ran a simple pipeline, and everything worked. Today, I want to evolve that by adding storage to our Fargate agents. AWS gives us 3 different options for storage in ECS Fargate. We've got EBS volumes, EFS file systems, and bind mounts. Each one has different characteristics for different use cases. So I'm going to try out each option in separate videos. And I'm starting with EBS, which is Elastic Block Storage, because it's first on the AWS documentation list. What are we doing in this video specifically? We're implementing EBS storage for our Azure Pipelines agents running on ECS Fargate. We're going to see how 2 agents can share data through an EBS volume, and we're going to walk through the infrastructure as code, and we're going to run a pipeline that demonstrates the persistence of data. So let's dive in. Before we get into EBS specifically, let's talk about what options we have. According to this AWS documentation, ECS Fargate supports these types of data volumes. So this column on supported capacity, what we're interested in is where it supports Fargate. And it says EBS for Elastic Block Store and EFS, as well as bind mounts. For EBS, this is block level storage that you attach to your Fargate task. Think of this as attaching a hard drive to your computer. It says here that it can be persisted when attached to a standalone task and ephemeral when attached to a task maintained by a service. It also lists the use cases here. It does the same for EFS and bind mount. So each option, as you can see, have their own use cases. And we will experiment and see with running pipelines whether EBS would be suitable for our use case. Okay, so what is EBS exactly? Elastic Block Store. It's AWS's block storage service. It is like a virtual hard drive that I can attach to an EC2 instance, or as of Linux platform version 1.4.0 to ECS Fargate tasks. Here's the documentation from AWS with regard to using Amazon EBS volumes with ECS. And it says here with Fargate, you need platform version 1.4 for Linux, and certain considerations here like IAM roles, and this one here, which says you must run the container as a root user. Now, before we jump into the cloud implementation, I just wanted to recap what we did in an earlier video when I was running Azure Pipelines agents locally on my Mac. I demonstrated persistent storage using Docker volumes. I had a Docker Compose file that looked like this. So this Docker Compose file ran 2 containers. One was agent 1 and another agent 2, where I use agent 1 in a pipeline for building, creating artifacts that it will save into that shared volume, and agent 2 is also mounting that same volume, shared artifacts mounting that shared volume, where agent 2 is used as the deploy agent to read the files that was written by agent 1. So that was the conceptual model. A shared volume that persists beyond the container lifecycle, and that's exactly what I want to replicate in this ECS Fargate model. Except instead of a local Docker volume, we're using an EBS volume managed by AWS. And this is the pipeline that we used, where I had these two stages. One is to build, where I'm using agent 1, creating these dummy files, zipping them up, and saving it to that shared storage, which is the artifact path I've defined here in shared volumes and in a subdirectory called artifacts. The deploy stage is using agent 2, which it reads from shared artifact folder, unzipping that file to test that and prove that it can use that shared storage. Okay, so let's do a walkthrough of the infrastructure as code. Starting with the Terraform template, collapse these so it's easier to go over them. So if you've seen the previous video, this is very, very similar. I've just built on this Terraform template. So I will gloss over those resources that we've reused from the last video. This one is the same. These ones are just the basic using the AWS provider. ECR repository is the same. Secrets manager, again, the same, where I've defined the secret. And this is where I store the path token for Azure pipelines, the pool name, and the Azure DevOps URL for my organization. Here we have a KMS key for EBS volume encryption, and we've enabled key rotation for security best practices. And it's going to be used to encrypt the EBS volume at rest. That's the alias of the KMS key. We have our ECS task execution role, which is the same as the last one. As we've discussed in the last video, this role is used by ECS for pulling the images from ECR. And we're using the task execution role policy plus additional policies permissions to be able to get secrets from Secret Manager. We've also now added a KMS access as well, so it can use the KMS key when it's accessing the EBS volume. Next is this ECS infrastructure role that is required for managed EBS volumes, and that is documented by AWS in that previous screen that I showed you, where it says you need this IAM role. With this permission, the Amazon ECS infrastructure role policy for volumes when you're configuring your volume at deployment, which is what we're going to do. And for that, we've attached the managed policy of Amazon ECS infrastructure role policy for volumes. We've also given it the additional policy for KMS access. And these last parts are the same for the ECS cluster, creating the CloudWatch log group, and lastly, the task definition. For the task definition, again, we're using the same network mode because we're using Fargate. We're only allowed to use AWS VPC. For our task CPU and memory, we're using our variable, which it will pull from the variables.tf file. The same with the operating system family and CPU architecture, we're still using ARM. And this is the new section that we've added, where we're defining the volume configuration here. We're naming it shared volume, and we're saying configure this volume at launch. We're using the same container definitions where we have a for loop based on the number of agent names we've put in our variables file. And for that container, we are defining the mount points here to say that the source volume is that shared volume. And within the container, we've named it the same so that it's consistent. Getting the secrets here from Secrets Manager for our token, our pool, and the Azure DevOps URL. And that's the Terraform configuration. It defines everything except the actual EBS volume, which is created dynamically at runtime. Now let's look at Docker file here. This is exactly the same as the Docker file we use when I ran the Docker containers locally, and we've created a directory called that shared volume. But this is the only change that I had to make by uncommenting this one to allow the agent to run as root. So you just have to be aware that you are running as root and there are security implications. But if you want to attach an EBS to your ECS Fargate task, then this is the only way. It's an AWS requirement, as we've seen in that AWS documentation. So let's create our infrastructure. I've already logged in. I can now go and create the infrastructure through Terraform. Okay, so it's finished building the infrastructure. Now I want to get the outputs of the Terraform build so I can continue with the building and pushing of the Docker image to ECR. Next, we're gonna go to our Docker folder to run and to build our image. Now, these are steps that we've done in the last video. All the same stuff. Next, we'll push the image to ECR. And while waiting for that, we can go over the next few lines. This one is the same as the last video. Again, we're just populating variables so we can create the task for ECS. So this one will get the KMS key, ARN, and the ECS infrastructure role, ARN. Okay, so it's done with the Docker push. Let's populate these variables next. And lastly, we're gonna create the task. To create the task, we're first gonna create this volume config variable on the fly with this JSON statement. And in case you're wondering where I got this from, we got this from this AWS documentation on volume configurations. So going back to our code, I'm just creating with the role ARN, the infrastructure role that we've created, the volume type, which is GP3, which is a SSD hard drive, and I've given it 5 gig, which is more than enough. IOPS and throughput, these are just the default values. I'm saying that I want to use KMS encryption, so this is true, and I've stated here my KMS key ARN. And because this is a block storage, it needs a file system. Your options are XFS, ext4, ext3. I've used ext4 because it's one of the most popular and most stable for Linux operating system file systems. And these are just tags. So let's populate our volume config variable and save it into this temporary EBS volume config file so that when we run our task, it is just plugging that JSON file into our volume configurations attribute in here. Now let's look at the console. We have our cluster and we can see the task. There's one pending already because we've run that AWS CLI command. And here in task, it is pending. We can look at the logs. There's none yet. And if we look at our agent pools, it's seeing it as offline and it should come up online soon. While we're waiting for these to come up online, I've already copied the pipeline definition here where we have those 2 stages, the build to be done by agent 1 and the deploy to be done by agent 2. Agent 1's online, I'll kick off the pipeline and we're gonna expect this to succeed. Okay, great. So as expected, my pipeline successfully ran with those 2 agents, which are 2 separate containers, but using the same data in that shared folder for writing the artifact and the other one reading the artifact. Let's have a look at the AWS console. So if we go back to our task, refresh that, it's saying that it's now running. You can see this volumes tab here. This actually points to an EBS volume in EC2 service. So I've already gone there. And as you can see, it is the same one, F8, ending in 0F8, that shared volume. And it's saying that it's in use. So if I stop this task, I expect to not see this volume anymore. Let's wait for the task to be deprovisioned the containers and detach the EBS volume, and finally delete that EBS volume. Now it's deprovisioning. If I go back to my EBS volume, it's already gone. So because this EBS is an ECS managed volume, ECS is detaching the volume from the task and then deleting the volume. So whatever data I have here, which is the artifacts that was stored by my pipeline, it's all gone. And we can prove that by creating a new task. Recreate this task. Let's wait for this new task to be provisioned. Okay, it's running now. We drill down to it. We'll see that the volume ID has now changed. So now it's ending in 64DC. This is a completely new volume that ECS has created for us for this particular task. So in theory, if I run this pipeline and just use the deploy stage, it should fail. As expected, it errored out because it can't find that build artifact in that volume that we're telling the container is it can't find that data from. So what does this mean for our use case? The way I understand it is that EBS provides persistent storage within a single task lifetime. If I have multiple containers in that same task that need to share data, which is what we had, EBS works fine. But if I needed to persist the data across multiple task recreations, the situation becomes more complex. Let's go back to the documentation here. So this documentation here has an attribute for termination policy, and this is delete on termination. So by default, if you did not define that, which we did not in our volume configuration statement, we didn't have any attribute here for delete on termination. If you don't define that, or this termination policy, let's go to the task definition. The easiest would be to create a new revision to see what the settings are in the GUI. Go down to volumes. So here in storage, it won't give us that option. But what I was trying to say is that the default value is that termination policy is true. And we've seen that when we've stopped the container, the EBS volume gets deleted. So let's do another experiment. I want to stop the task. Let's stop this. Wait for it to deprovision and delete the EBS volume. And go back to our volume definition. Actually, I'll copy this bit, paste this into our definition, then recreate our task. Go back to our console. And we now have the new task being provisioned. So with this configuration, so I forgot to change this to delete on termination to false. Delete this task, stop it, rerun this task. So we should now have our newest one with the deletion termination policy set to false. And you can do the same by running a new task here, selecting this, and here in volume, you can define the size, the throughput and the IOPS can stay the same. And it is this termination policy switch that you can untick. Select ext4 and select your role, infrastructure role, and your KMS key, and hit create. So that's another way of creating your task with the deletion termination policy disabled. Let's wait for our agents to come online. Okay, it's online. Let's run our pipeline again. Okay, so it's successful. Now I want to stop my task, and it should go into deprovisioning mode soon. Now it's saying the attachment status here is deleted, and this is the volume ending in A64DC that I expect to see, which is A64DC. And because we disabled the termination policy, this should stay. It's still saying as in use because it's still deprovisioning, and it's changed the volume state to available. Now here's the thing. We won't be able to attach an existing EBS volume to a new ECS task. And I can prove that here if I click run a new task. There's no option here to reuse or attach an existing volume. It does, however, give us this option to state a snapshot ID. So what we can do is create a snapshot out of this volume. I can say agent snapshot. And now that we've created snapshot, I'll copy that, paste that here, and I want that to delete on termination. And I won't worry about encryption for this. Oh, its snapshot is still pending. It is not ready yet. Okay, it's complete now. Let's try that again. Okay, it's launched the task. So what is this experiment that I'm trying to prove? I want to run the pipeline now when the agents come online and just run our deploy stage. But unlike the first go, when we stopped the task and recreated the task and ran just the deploy stage, it failed because there was no data that it found in that shared volume. Now, with having gone through the disabling of the termination deletion policy and then having that same EBS stay, creating a snapshot out of that and recreating our ECS task, using the snapshot to recreate the new EBS volume that our task has created, we expect the deploy stage, just running the deploy stage without running the build stage, to be successful. So we expect the deploy stage to be successful even though we're not doing any build. Looking at our volumes, there's now a couple of them. The first one is the one that was based on the snapshot, and this is the live one. And we can see the volume state, it's in use. This one is available, which I can safely delete because it's now no longer being used. All right, it's online now. So I want to just run the deploy stage without building anything. Okay. Now this was successful. It found the data, the build artifacts, from that snapshot that ECS has used to create that new EBS volume for us. Okay, this is great. So what I'll do is not to forget to clean up. Let's stop this task, empty our ECR container, delete our snapshot, and do a Terraform destroy. Make sure that we're not gonna be charged by AWS for those demo resources. Okay, so let's talk about what we've learned. First is to be able to use EBS with our ECS Fargate tasks. There are some EBS-specific requirements. First of which is you need Linux platform version 1.4.0. Second is you need that IAM role, which is an infrastructure specific role, so that the ECS task is able to create and manage the EBS volumes, including detaching and deleting those volumes. Thirdly, you need the containers to run as root. This is an AWS requirement, which is not ideal from a security perspective, but that's what we get. Fourth, you need to configure the volume at launch. In the task definition, you use that configure at launch is equal to true, then you provide the actual volume configuration in the run task command as a JSON structure. This gives us the flexibility to specify different volume sizes or performance characteristics for different tasks. Another one is we can only attach new EBS volumes to Fargate tasks, not to existing ones. This is a limitation for me, for my use case. So even if you set delete on termination to false, To preserve a volume after a task stops, you cannot attach that existing volume to a new task. The only way to use data from an existing volume is to create a snapshot and then initialize a new volume from that snapshot using the snapshot ID parameter. This restriction makes EBS not practical for my scenario where I want something that persists across task recreations. Next is the volume is attached to a single task. The volume lifecycle is tied to the task lifecycle. With regard to security, EBS supports KMS encryption for data at rest. This is great for compliance and security. So you create your own KMS key, enable key rotation, reference it in the volume configurations, and then ECS handles the encryption and decryption transparently for us. Okay, I hope you learned something from that demo. This is the first of those 3 storage options for ECS Fargate. The plan is to explore the 2 other types, EFS and bind mounts. Thanks for watching, and I'll see you in the next video.